to solve problems. Not mechanically, thinking what you want to do. You go step by step, backwards or forwards, or you meet in the middle. Learn how to solve problems. Don't memorize problems. Because then you will always be 4 years in science or math classes, you will be struggling. You don't need to struggle, you can have fun. Okay? Right, so the middle, I see. You want to write on paper? Well, I can do that. That's not a problem. Hopefully I have some paper here. Okay, let's do this problem now. I think I need a thing. Somebody is thinking about the teacher, huh? Is that good? Don't you like people to really think about you? What you need? Huh? How does that work? Think about other people, then they will start thinking about you. It's going to be sweet, really good. It's not happening unless you start yourself doing it first. Did you notice that? So far in your life? No? Yes? Huh? Okay, so let's do this problem now. Since it's in my hand, I might as well show it to you, right? So the problem says, how many unpaired electrons are in the ground state electron configuration of manganese 2 plus, right? So how do we do this problem? We write the electron configuration of the atom itself, and then we go to the ion, right? So we want for the manganese. So we go to manganese atom, and we go to the periodic table, of course, right? Remember? So if you go to the periodic table, fortunately I forgot my pointer. No, I'm looking for the pointer, but it's in my different bag, so that's okay. So if you go to the periodic table, right, what are you going to get? The electron configuration of manganese is going to be, can you find manganese? Okay, number 25. You can go backwards, and the first noble gas that you need is going to be 18. So that's argon, right? So that would be manganese in the ground state electron configuration will have the same electron configuration as argon, and then on the top of that we'll have what? Let's go. Manganese is in what period? 4 period, right? 1, 2, 3, 4 lines horizontal, 4 period. So it's going to be 4s2, right? You see that? 4s2. And then we go n minus 1, that means 3d, how many? scandium 21, 1, 2, 3, 4, 5. So it's going to be D5. Everybody with that? Okay with that? Right? That's what you will do. Just like any other time for any atom. Right? Now we want to find out for the ion. So in order to go for the ion, so this is for the atom. In order to go to ion, you rearrange this. Rearrange. Now why? You will find that out when you take 2C. Okay? This is not the time to talk about it. So we rearrange this in such a way, in other words, we write in such a way, we don't shift electrons from one subshell to another subshell. That will change the energy. We do not shift electrons. We just write the symbols in different positions of the paper. So the energy is the same, right? I just rearrange the writing, right? The energy stays the same. And I'm going to do it in such a way that the first quantum number is going to be in an increasing way, in increasing order, okay? The first quantum number. So if I do that, then it has to be 3d5, 4s2, right? So you rearrange. You go to the ions of transition metals. You have to rearrange it. You put whatever electrons you have in the valence shell, including the electrons, in a way of increasing first quantum number. When you do that, you are ready to go into the ion. So this is still atom, right? Atom, same energy. I didn't shift electrons from one orbital or shell or subshell from one to the other. No, I didn't do that. So it's the same energy, right? Same thing. I just rewrote it in a different way. Now I want to go to manganese 2 plus for the ion. What I do is, how many electrons? I went for manganese 2 plus. Right? The problem is manganese 2 plus. That means minus 2 electrons. And you remove the 2 electrons that are far to the right. So these 2 electrons are going to be gone. So if this is going to be gone, then what it stays is manganese, S argon, 3d5, and that's it. For manganese 2 plus ion. This is the ground state electron configuration for manganese 2 plus. And we say it's a D5 system. That kind of terminology we use many times. Manganese 2 plus, we say it's a D5 system.